Well, hello. We're ready for section 3 of chapter 2, Graphing Polynomial Functions, part 1. Let's start off with a little video. I'm going to show you this cubic function in the calculator. I've already got it typed in. I'm going to hit graph. And you can see this is a function that starts out negative, goes up, does a little dip right there, and then it goes on back up. But then, if you notice, if I type the exact same function, only I put a negative in front of it, turn off the other function. Now, it's going to look very similar, only instead of finishing up, it finishes down. That's all because we threw that negative in front of there. And that, my friends, is what we're going to start doing today. We're going to start, if I can get this video out of here, sorry about that. We're going to start sketching graphs of polynomial functions. So let me get my laser right here. Now I know there's a lot on this screen that you're going to want to copy down, but that's alright. So here's a function where the curve rises. It finishes up. It starts down and it finishes up. It's got some local relative extrema over here, relative extrema. That's where it has like this hill. That's called a local relative maximum, and this valley is called a local relative minimum. Now it finishes up because the value of a in the function ax cubed is greater than 0. Notice over here on this side, when a is less than 0, the curve finishes down. As you look the graph from left to right, it finishes down. Again, this valley and this hill, those are relative extrema. And the curve, once again, falls here, or it finishes down. Here's the multiplied version of a cubic polynomial, and here's the factored version. Notice a has been factored out. A will just be some positive coefficient or negative coefficient. Where n, m, and p are the zeros. Notice there are 1, 2, 3 zeros because this is a cubic function. Alright, pause this video and copy the rest of this screen. Alright, so what we're going to do is we're going to sketch a graph on our own now. We're going to sketch f of x equals x plus 1, x minus 1 times x minus 2. Now, I was awfully nice to you because this is already factored. Now, since it has 3 zeros, I know it's a cubic function, which means it either does one of these where it finishes up, that's if a is positive, or it does one of these. These kind of look like snakes. If a is negative, it finishes down. Well, since our a is 1, since you can't see it, that means this is our winner. We know it's going to have to finish up. So since we have our function as this, we know that if we set it to 0, we're going to get 3 zeros. What are they? What are our zeros? They are... Here, let me even write the word 0 because I'm so cool like that. X is negative 1, x could be positive 1, or x could be 2. So this is what we do. Here we go. Negative 1, put a big old fat dot. Positive 1, big old fat dot. Positive 2, big old fat dot. 1, 2. Put a little 1 and 2 there so I know what the scale is. Alright, now we said it finishes up. So if it finishes up, it must start down. And it comes up, does a hill, goes back down, then it changes its mind, makes a valley, and finishes up. That's a nice sketch of a polynomial function. You know I'm not going to let you get away without talking to me about domain and range. Oh yeah, that's right, they never go away, folks. But on a polynomial function that's continuous and goes on forever, it's actually rather easy. The domain for x is all real numbers, because it never stops going left, and it never stops going right. It's defined at every x. The range, I should have said f of x here. Look at me, getting ahead of myself. It goes up forever, and it goes down forever. This curve, it's going to go up forever, and it's going to go down forever with no discontinuities. That means the range is also all real numbers. All real numbers. Alright, cool. Nice. Let's do one a little bit saucier. Now this one is not as easy because it's not factored yet. Now it's still a cubic. It's still a cubic. Factor out GCF if possible. Factor out GCF. That's a little strategy that you're going to want to use in this section. So what we're going to do is we're going to pull out, well, first thing I'm going to set it to 0 because I want to find the zeros in order to sketch the graph. You have to find the zeros. Those are the magic points here. Pull out that negative, pull out a negative x. Now that changes your sign. So it's x squared minus 4x minus 5. And I believe that factors further. 5 and 1 plus 1. And dun da da da. What are your zeros? X could be 0. X could be 5. Or x could be negative 1. Those are your possible zeros. Another important piece of the puzzle, folks, is the value of a. A is negative 1, which is less than 0. And since this is a cubic function, it does one of these snakes. Starts up, changes its mind, and goes back down. That's how this function should kind of look. So, let's sketch it. Big O dot at 0. Big O dot at negative 1. 1, 2, 3, 4, 5. Big O dot at 5. Alright, here we go. Start up. And then go down. Oh, change its mind. Comes back up. Oh, change its mind. It goes back down. Guys, this is a lot more fun if you make the sound effects with me and I can't hear you. So let me hear you when you're making those sound effects. Make sure you label the x-axis. That way I know, at least the scales on your x-axis. That way I know what your scales are. Alright, let's keep on. So, in general, quadratic functions, they're parabolas. If a is positive, they open up. They have one relative extrema. It's a minimum. If a is negative, they open down. They have one relative extrema. It's a maximum. Okay, if it's a cubic, it kind of does the snake thing. It goes up, changes its mind, goes down, and comes back up. Notice it finishes up when a is bigger than 0. It's got one max, one min. If it has a negative a, it starts up, change its mind, and go back down. It's got a min and a max. Alright, the quartic functions. The quartic functions look kind of like W's. Now, if a is positive, that's what it looks like. It's got two minimums and a maximum. That's on a generic one. They may, sometimes they just have one maximum, but those are special cases. Not maximum, minimum is what I meant to say. And if a is negative, both arrows face down. Both arrows face down. Boom, boom, boom. Do you notice a pattern here? When the degree is even, both arrows face up. Up, up. Or both arrows face down. Down, 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 down. That's when the degree is even. Remember, it was quadratic, degree 2. Quartic, degree 4. When the degree is odd, one arrow down, one arrow up. One arrow up, one arrow down. When we get to quintic, we have another odd degree. Guess what? That means one arrow down and one arrow up. Here's what it does. Ready? Starts down, and it goes whoop, 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 whoop. Just like that. That's what it does. Look, we got a max. We got a min. We got a max. We got another min. Alright? And if the degree is odd, or degree 5, and a is negative, it finishes down. So it goes down, whoop, 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 whoop. Just like that. We got a min. We got a max. We got a min. We got a max. Cha-ching. Alright, so odd degree, arrows go opposite ways. Odd degree, opposite ways. You might want to write that. Odd degree, opposite ways. Even degree, same way. Even degree, same way. Nice little easy pattern that you should have memorized. It's going to make your life easier. Number of relative extrema. Let's see here. If it was a 5th degree, it had 1, 2, 3, 4 extrema. If it was 4th degree, it had 1, 2, 3 extrema. If it was 3rd degree, it had 2 extrema. If it was 2nd degree, it had 1 extrema. There's a pattern there. The number of extrema is always the degree minus 1. Degree minus 1. Alright, well let's take these new tricks you've learned. Practice a few more. Here, sketch this graph. Now, I was nice to you because they're all it's already factored. Already factored. And since there are 4 of them, we know he's quartic. Make that note. Since there are 4 zeros, we know he's quartic. Alright, talk to me about what your zeros are. X could be negative 3. negative 1, 1, or 2. Those are all the places it's going to cross the x-axis. Also, we need to know the value of A. A is bigger than 0 because A is 1. Sitting right there in front of everything. See it? That means, since it's quartic, both arrows will face up. It's going to do something like that. Something like that. All right, here we go. This is the best part. 1, 2, 3, negative 1, 1, and 2. Sketch me. Here we go. All right, starts up, and it goes whoop, 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 boom. There it goes. Finishes up. Crosses at negative 3, negative 1, 1, and 2. And that's it, folks. There you go. You just did a rough sketch. And you can check these on your calculator. That's the beauty of it. That's the beauty of it. Make sure it's nice and smooth. Don't give me any zigzags. Nice, smooth, rolling curve. Let's try another one that hasn't been factored. So you know what to do. Pull out the GCF, which is x squared. Leaves you x squared minus 16. Okay. X squared times x plus 4. X minus 4. We factored even farther because we're cool like that. Okay, so x could be 0. X could be negative 4, or x could be 4. Now wait a minute. This is a quartic function, which means we should get 4 answers. Why aren't we getting 4? Well, technically we are. See this squared right here? The 0 that we resulted from that was 0. Guess what? He is a double root. A double root. What that means is, if you have a double root at 0, the graph just kind of comes down and gives a little kiss and goes back up. Or if it might go up and come back down. Just give it a little kiss. That's called a point of tangency. That's where the graph is tangent to the x-axis. Tangent to the x-axis. Okay, real quick here. A is again 1, which means it's greater than 0. And since this is a quartic function and it's greater than 0, it's going to do something like this. Zoom, zoom, zoom. Something like that. Both arrows will face up. That's the important part. Both arrows face up. All right, so here we go. Let's do our sketch. Boom, boom. All right, negative 4. 1, 2, 3, 4. 1, 2, 3, positive 4. And 0. Dots. Those 3 places. Put them. Get them there. Yes. All right. All right, so we know that both arrows face up. So start up and come down and go whoop. Now be careful. When you get to 0, it's got to be tangent. So it goes up to 0 and just gives a little kiss. And then it comes back down and it goes back up and finishes up. Boom. All right, so we got a 0 at negative 4, a 0 at 0, but it's actually a double root. That counts twice, and a 0 at 4. That 1 plus 2 plus 1 totals our 4 zeros that we needed. All right, awesome. Okay, so now I'm going to flip the script on you, and you're going to give me f of x given the function. So here we go. The zeros are negative 4, 1, and 3. So make that note. Making a note. Here I am, just making a note. All right, negative 4, 1, and 3. Those are my zeros. Also, note that this bad boy finishes down, like downtown. A, it must be less than 0, that means. Because A is negative. A is negative. Alright, and since I gave you the zeros, I'm going to tell you, since I gave you the zeros, I'm going to let you assume that A is negative 1. Since I gave you the zeros, I'm going to let you assume that A is negative 1. So here we go. Let's do our sketch. Remember, it's A times the x minus the first 0 times x minus the second 0 times x minus the third 0. Alright, and I said that you can assume A is negative 1 here since I gave you all 3 zeros. It won't be like that in the next example. Alright, x plus 4. That came from this guy right there. X minus 1 and x minus 3. That's your function, f of x or p of x, whatever you would like to call it. Notice, it was what kind of function? It was a cubic function. That's why it has opposite end behavior. One arrow goes up and the other arrow goes down. And since it finished down, A was negative. I'm just going to keep repeating this. Okay, last one here. Last one. Now on this one, I know I gave you the zeros again, but I also gave you a separate point down here, -6, -4. And since I gave you that point, I'm going to ask you to find A. I'm not just going to give it to you. You're going to have to find A. I'm not just going to give it to you. Alright, so here we go. F of x is equal to sum A times x. It looks like one of the zeros over here is 1, 2, 3, 4, -5. So that'd be x plus 5. The next zero looks like is -2. That'd be x plus 2. And the next zero is just 0. Well, that would just be x. Now, notice that the arrow finishes up. Up. Well, what's that tell me about A? What's that tell me about A? Well, that means A must be a positive number. That's important. Remember that. A must be a positive number because it finishes up. Do you catch that? A is positive because it finishes up. Now, I gave you a separate point. I wonder why I gave that to you. Well, it's because you need to find A. So, if you have x and y, what can you do with them? You can plug them in for x, 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 and f of x, which is really just y. All right, here we go. So, y is -4. We don't know A. X is -6 plus 5. The second x is -6 plus 2. And then the last one is just -6. Okay, solve for A. That's -4 times A. That's -1, -4, -6. -4 equals -1 times -4 times -6 is -24. Solve for A, you get positive 1/6. Cha-ching! Alright, now that you got A, give me my function. Let's throw a little therefore in here, just to make it kind of nerdy. Alright, so A is 1/6. Let's put the x that gave us 0, put it first. Alright, and then we would have x plus 5 and x plus 2. And you know what? If you wanted to multiply that all out, you could. But why not just leave it in factored form? Because the directions just said write a function for f of x. It didn't say if it had to be factored or if it had to be multiplied out. Just leave it like that. It's perfect. Nicely done. Alright, folks. I'll tell you what. That's all I'm going to throw at you for part 1. You enjoy part 1 and you come back with a smiling face for part 2. I can't wait. I hope you can't either. I'll talk to you later. I'm out.